You switch to Delta Lake, and your queries, they're still running slow. Your Databricks bill blew up. Why? You are making the same mistake that every engineer and architect makes in this transformation. You are ignoring distribution and partitioning. This is the real unlock between engineers stuck at 80K and those that are exceeding 180K. In the next minutes, I'll show you how to unlock speed and cost savings beyond your imagination. Let's be honest, moving to Delta Lake isn't cheap, and it's supposed to solve your scaling problems. But here's what I see time and time again. Teams are spending tens of thousands a month on Databricks, and their jobs are still running in batch overnight. Why? Because even with modern architecture, if you treat your data lake like one big junk drawer, every query scans everything, and you end up paying more for the same pain. Here is the real story. A retail company I consulted with was shelling out $50K a month for Databricks compute. Their ETL jobs were still running in batch overnight, and the team thought that's just what it costs for big data. The reality, all of their data, years of transactions, millions of customers, was all dumped into a single partition. Every query, every report was forced to scan the entire data lake every single time. When we fixed their partitioning, splitting by transaction date and region, the bill dropped from $50K a month to $12K a month. That is a $456,000 annual savings. The engineer who led that project ended up with a $40K raise and a promotion to lead engineer. That is the difference between doing the job and owning the outcome. Partitioning means splitting your data into manageable, meaningful chunks, like by date, by customer, or by region. So that way Databricks can target exactly what you need to find fast. Think of it like searching for a specific book. If every book is piled up, you're going to spend hours digging. If it's shelved by genre and author, then you'll find it in seconds. Distribution, on the other hand, is how data gets spread across your cluster. If it's all stuck in one spot, the compute nodes sit idle while there's one over here working overtime. Done right, every node gets a fair share. So that way, jobs fly and costs drop. You might be wondering, does partitioning matter if I'm already using column-based databases like Delta Lake? Here's the key. Partitioning matters in both row and column-based systems, but its impact is completely different. In traditional row-based databases, think MySQL, Postgres, partitioning helps you break big tables into manageable pieces. But every query is still reading entire rows, including all those columns that you might not need. In column-based systems like Delta Lake, partitioning is even more powerful. Now, not only can you limit your rows you scan, but you're also pulling only the columns you need. This means that you go from reading terabytes down to just a few megabytes for the same report, if you're partitioned and distributed things in the right manner. The best paid data engineers understand both. How to pick the right columns for analytics, column pruning, and how to use partitioning and distribution to make every query laser focused so you can save on compute, storage, and time. If you skip this, you might as well be running a columnar database like a row-based one, and that's the fastest way to burn through your cloud budget and stay stuck at 80K because your company's still paying those 50K a month bills. This is why companies pay for columnar and partitioning expertise. Anyone can move data to Delta Lake. Only top engineers know how to architect it for blazing speed at rock bottom cost. So, how do you know if you've got partitioning or distribution problems? Here are some questions that I never hear from junior engineers, but senior engineers ask all the time. When's the last time you checked your partition sizes? Are some 10 times bigger than others? Something to look at. How many files are in your busiest partition? And do you know why that matters? Are your slowest jobs always hitting the same partitions, or are they evenly distributed? Do your job logs show one node maxed out while the others are sitting idle? If you never thought about these questions, you are leaving speed and money on the table. You want to test if your partitioning is holding you back? Here are some of your warning signs. Queries that should run in seconds, but take minutes. Job runtimes that get slower as your data grows. And cloud bills going up even though your workload hasn't changed at all. You've got cluster dashboards showing data skew or lopsided resource usage. If any of these feel like they're spot on, then partitioning and data and distribution is your bottleneck. And here's the thing. If terms like data skew, shuffle, Z-ordering sound unfamiliar, then that's probably your next step to investigate. These are some advanced strategies for fixing even the trickier problems with large-scale data, and we deep dive all of them in my masterclass I'm creating. If you can walk into an interview and confidently explain the business impact of partitioning and distribution and how you saved your company time and money, you're going to stand out from 90% of the candidates out there. The best paid engineers aren't just technical. They translate the smart architecture they understand into real business results. So here is your next move. Audit your biggest table's partitioning. Check and see if you have that partition that's 10K bigger than the rest. Look at some of your slowest queries. Are they scanning everything or are they laser focused? And ask, if I partitioned or distributed differently, would anything change? If you want to know the how step-by-step, no guesswork, I'm building that masterclass. You can join the waitlist right now, and the first 50 signups get some exclusive bonuses and early bird pricing. While you wait, check out this top 10 Databricks mistakes, because every 100K mistake starts with ignoring distribution and partitioning.